Today's video is all about the Y-intercept. How do you find it? When do you find it? Why do you find it? The Y-intercept is interesting because it's one of the easiest significant points to solve for, but it's also one of the most impactful. Let's start with a set of axes here. Now let's say I've got some curve that goes through those axes, right? Somewhere along the way, that curve crosses the y-axis. Now in this case, it looks like it crosses the y-axis above 0, so it would be a positive number, but let's leave that out. It could cross anywhere. That y-intercept has a pair of coordinates like any other point, an x and a y. Now, we don't know what this y is, right? We don't know this distance here between the origin and the y-intercept. But what we do know, what we absolutely 100% do know, is what the x value is of that point. Whether that point is there, or here, 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 no matter where on that y-axis the y-intercept is, I know that the x value is 0. For all of these, x equals 0. The y values are all different, sure, but the x value is always 0. So, if I want to find the y-intercept of any equation, all I have to do is make x equals 0 and then solve for y. That's it. That is always the case when you are looking for the y-intercept, no matter what function you're dealing with, by the way. This is not just for quadratic functions. This works for any equation forever. Okay, let's do a really quick example, okay? Example 1. Find the y-intercept. And we'll say our equation is y equals 15x squared plus 35x minus 12. And we want to find the y-intercept. Well, some of you may have already noticed that the y-intercept is going to be negative 12, right? But that's not some magical number. Let's use our actual method and double check that. Okay, well, if I plug in x equals 0, I get y equals 15 times 0 squared, right? Instead of 0, I put in, or instead of x, I put in 0, plus 35 times 0 minus 12. Well, 0 squared is 0, times 15 is still 0, 35 times 0 is still 0. So yes, we do end up getting y equals negative 12. Therefore, our y-intercept is 0, negative 12. Now, when do we find the y-intercept, right? Other than when I say find the y-intercept, that's obvious. But a lot of the time in word problems, they don't specifically say find the y-intercept. They'll instead say things like find the start point, right? With our tile patterns, it was figure 0. If we're talking about like a ball flying through the air, which we will, you could say when the object was thrown. In all of those situations, basically what they're saying is when we start the timer, right? If I have a stopwatch and I start that stopwatch, it always starts at 0, 0. Right? So the moment I hit the start button, that is time equals 0. That is essentially the y-intercept if I was to graph whatever it was that I was graphing over time. Okay, let's look at a couple of examples of practical problems involving the y-intercept, and then we'll be done. Sarah kicked a ball in the air. The function f, that's this graph right here, models the height of the ball in meters as a function of time in seconds after Sarah kicked it. The question is, how high off the ground was the ball when Sarah kicked it? So again, this is an example of a kind of problem that is kind of sort of subtly asking you for the y-intercept. It's not going to say find the y-intercept, because in the real world people don't talk like that. Instead, it's saying how high off the ground was the ball when Sarah kicked it. Well, when she kicked it, our time, since we start the timer when she kicks the ball, time is going to equal 0 seconds at the moment that she makes contact with the ball. So again, we are looking for the y-intercept. Looks to me like the y-intercept is right there. And it looks like it is 0, 1. Okay, so at 0 seconds, the ball was 1 meter off the ground. So the answer to our question is 1 meter. And we got it just by looking at our graph. No real math necessary. That was example 2. Let's do one that actually requires you to do a little bit of calculation. Example 3. A hovercraft takes off from a platform, or in this case, the water. Its height in meters, x seconds after takeoff. Now let's keep that in mind. Time is x, which means that height is y. Okay? Height is y, and time is x. What is the height of the hovercraft at the time of takeoff? Well, at the time of takeoff, assuming that that's where we're starting our timer, that's going to be time equals 0 again. The moment the hovercraft takes off, we hit that stopwatch, so to speak, and it starts at 0 and then begins climbing up. Although in this case, I guess we're using x instead of t. I generally prefer to use t for time instead of x, but we'll use x instead, that's fine. So all we have to do is figure out, well, let's plug in x equals 0 and figure out what h of x is. H of 0, note that it's h of 0 instead of h of x because x is 0. I'm just taking out the x and putting in a 0 wherever I see it, is negative, parentheses, 0 minus 11, right? Just again, substituting x and 0, times 0 plus 3. Okay, that gives me negative 11, 0 minus 11 is negative 11, times positive 3. Negatives cancel each other out. We get positive 33 meters. And that's really all there is to the y-intercept. The y-intercept is, again, one of the simpler but also one of the more useful things that you can possibly calculate, because a lot of the time it gives you a good idea of what was happening right at the beginning. Whatever situation we're talking about, what happened when it started. All right, I hope that's helpful, and I will see you in the next video.